Okay, testing the Woodo Mark 1 previewer. So imagine I have a V in, like so, and imagine I have a V out, like so. Now all of these are just plus and minus, but it could be AC, so that doesn't really have any meaning. But we have a voltage in and a voltage out that we can measure. Okay, pretty straightforward. Now, if I were to connect a resistor to this, like so, so there's my resistor, and I connected, just going to use dotty lines on this, and I connected my resistor to V out, regardless of what value the resistor is, that's not important. I'm just going to call it R1, but if you feel more comfortable with numbers, then let's call that 1 kilo ohm or 100 ohms, or use your imagination, anything you want. And obviously this side goes down to ground, like so. If I connected this end of R1 to V out, say for example I put 5 volts V in, I know a lot of people feel much more comfortable with numbers being put in place. If I put 5 volts in there, what would you expect to read if I put a voltmeter here? So we could draw that in, I suppose, but it's fairly pointless. If I put a voltmeter here, what would most people expect to read at the output there? Well, 5 volts. 5 volts, because there's no volt drop. There's no current flowing. There's no current flowing from here to the multimeter, because the multimeter has an infinite input impedance. Now imagine what we do is this, that we connect a resistor from this point here down to ground. So we've got these 2 points here, and now this goes to V out. So what we've got here now, we've got resistor R1 and resistor R2. Well, you can imagine current flowing now through here, because it's actually got somewhere to go, because it can go down here to ground. Obviously a tiny amount goes through here into the voltmeter, but that's negligible. So we've got current flowing down through here. One would expect a volt drop across here and a volt drop across here, according to Ohm's law. Okay, and what we'd like to try and work out is actually what the proportion of the volts dropped across here and the volts dropped across here is, and also we'd like to know what the voltage is here. In other words, V out. Okay, so we need to think about how we're going to solve this problem. So we've got good old-fashioned Ohm's law, V equals I times R. Okay, now we've got current, let's call it lowercase I. We've got current I flowing through here and current I flowing through here. So I will be the same in both cases as it flows through the 2 resistors. Okay, so what does that give us here? That gives us R1 times I, according to Ohm's law. Well, what does that equal? That equals the voltage dropped across here. So let's call that VD1, because it's across resistor 1. And this one here we'll call VD2, because it's across resistor R2. So VD1 is equal to R1I, and VD2 is equal to R2I. Okay, well, where does that get us? We don't really know much more than we did before, do we? Well, have a little think about that for a minute, if you would.